and keeping us. Thank you. Thank you. But today it's different. Maybe a quick activity to keep us active and invite people who are coming in now. So, first, 10 seconds are very important. When I raise, clap should be very high. Should be together. Should be when I put down my hand, it should be silent, but you will be clapping without sound. Slowly rise. The clap sound should increase. When the hands are up, clap should be on the high sound. It should be like that. Can we play that? எனக்கு காது கேட்காது first. So after lunch it should be very heavy. People who are outside, please come in. We are clapping and we are ready to invite you with our claps. பின்னாடி இருக்குங்க யாரும் கை தட்டலையே. That side, to my left side, nobody is clapping. We welcome you with high round of applause. My hand is still upside, sir. You have to keep clapping. Nothing will happen. When your palms come together, it is good for the health. All your acupressures come together, that's why we clap. It's not like this. It should be like that with full sound. No sound. That side, sir, near the TV, nobody is clapping. I am active from the morning. You guys are only sitting. I should have given us exercise, stands and walk and dance like that. Okay, both the hands are up now. The sound should be really on its peak. Let's give a big round of applause for ourselves and the panel which is going to be on the stage for a power-packed session on this new technology, what they are discussing. Let's keep our brain, eyes and ear very sharp because we have a very heterogeneous and mixed talents in this panel. Really a fast-paced panel, I should say. We welcome Divona to handle the session. Thank you very much. Okay.
Welcome back. So good afternoon, ladies and gentlemen. I hope you all had a refreshing lunch and some time to network. So let's bring that same positive energy back into the hall as we continue our session 5. So introducing the theme of the session, AI-powered transformation and data integrity. So as we all know, artificial intelligence is no longer a buzzword. So it is reshaping industries, creating new opportunities, and most importantly, bringing trust and responsibility into data-driven decision-making. So join me in welcoming our today's chairperson, Dr. S. Rajkumar. Please give a round of applause. President, Rane Madras Limited ECD, onto the stage. Welcome, sir. Let me introduce the speakers of the session. I'm deeply honored in welcoming our eminent speakers of the session, Mr. Chandrasekhar Bharati, Managing Director, ACE Micromatic MIT. Let's give a round of applause. Mr. R. Abhilesh Chakravarti, Managing Director, ACE Robotics Private Limited. Welcome, sir. Colonel Gaurav Singh, Chief Consultant, Technical, Pinkerton. And Ms. Hemeshwari Ranganathan, Principal Product Strategy Manager, Oracle. Sorry, it's Ms. Hamseshwari Ranganathan. Sorry, ma'am. And the session coordinator, Kirti Vasan. I'm honored to introduce the session chairperson, Dr. S. Rajkumar. Dr. S. Rajkumar is currently president at Rane Engine Valve Limited, having a long professional career in various functions at Nippon Seiki, Apollo Tyres Limited, Lucas TVS, and Mahindra. Dr. SR is a BE mechanical engineer from Annamalai University, has a MTech in industrial engineering from College of Engineering Trivandrum, and also an MBA marketing from IGNOU New Delhi. He has a PhD from the College of Engineering Gindi and Inter ICWAI. He is a Six Sigma Black Belt and lead auditor of IMS. He has many publications which include Journal of the Indian Institution of Industrial Engineering, AIMA, and JUSE. Currently, he is the co-convener of CII, Chennai Zone Manufacturing Panel, and president of ISQ Chennai. NIQR is happy to present Dr. S. Rajkumar as a chairperson for this session. Over to you, sir.
Good afternoon. Good afternoon to every one of you. Good. I think it is very difficult to attend the post-lunch session, I know, and also equally difficult to host the post-lunch session. But fortunately, you have speakers on the dais who will keep you awake. They have a very good power-packed presentation today. So now the theme for this session is AI-powered transformation with data integrity, right? So what is this AI? Artificial intelligence. What is that? I just asked Google what is it. Google said, ability of the machine to display human-like capabilities such as reasoning, learning, planning, and creativity. Do we see all this today? Some response is required, then only you can be awake. Right? See, I will just tell you an example in my own case. See, in my organization, I used to get mails from my colleagues. Suddenly, in the last 3-4 months, I am seeing some of my colleagues who cannot even write 2-3 statements correctly in grammatically are writing excellent English. How do you think this is? Yeah, even if you take Google in Gmail, it automatically asks, when I write some type of mail, it asks me, Alt-H, polish. So you write anything, scribble anything, and say polish, it writes a wonderful reply mail. Then it says elaborate, you want to elaborate. It asks whether you want to shorten, shorten. Right? So that is AI. So AI is already there. Not only that, when you book a ticket for airlines, whom do you think is fixing your the price of the ticket? It's again. And similarly, when you go to the airport, you are being monitored by AI. And when you enter into the flight, after the door is closed, AI guides the pilot. So AI is everywhere there. Whether you realize, recognize or not, we are already into it. So the message here is, if you don't change and try to adopt AI, you will not be there. Have you heard about Kodak? What happened to Kodak? Kodak is bankrupt no more. Why? Yeah, that's what people think, because Kodak did not change with the time. They did not change with technology. It's not true. The truth is, they already had the digital technology, digital camera. But like my organization, in that organization, the marketing people said, the marketing head said, no, we are selling so many rolls, don't kill it. And every zone I am able to make so much of money. Why are you bringing this digital? Because it is going to be only one time. And that's where they lost. So we need to be abreast of technology, and also we need to use that technology. You should not forget it. So that is, please remember this Kodak thing. So I'll just, somebody told me when you start the session, just give some brief. People talk about big jargons, plus give me a brief. So I thought I will just give a brief, and all the power pack presentations will be done by the eminent speakers here. Right? So when you see the definition of AI, as I said, it is all reasoning, learning, planning, etc. But there are three types of AI people talk about. One is narrow AI, which we said is directly, no, it is independent of the learning. There is something called artificial general intelligence, AGI. There it has some sort of learn, think, and perform similar levels to humans. And the other one is superintelligence, which will be better than the humans. Now, when you talk about AI, people think some jobs will be lost, something will be moved out. Okay, of course, in the process, that can happen. See, when computerization started, I remember in the banks, when my earlier days, when you used to go to the bank, there used to be a big ledger. The clerk used to, when you give the passbook, he will write down in the ledger and then copy that in the passbook and give. Today, it is not there. None of you would have seen that now. But do you mean to say that the jobs are lost? The jobs are not lost, but the skill level of people have to be upgraded. So upskilling happened, and it will not be. Similarly, when you look at the AI, I think you should look at, rather than automation, on augmentation. It is going to help using the intelligence. That's how it will get acceptance, and that's how the high chance of failure will be removed, and the cost also will be there. So then, what are the different types of AI? I am not going to read this theory. Just to give, traditional AI is like what we talk about, the data analysis, and then the giving the capabilities like forecasting, etc. Then you have something called generative AI. Generative AI is, in simple terms, if I want to tell you, for example, if you say there is you want to duplicate some picture or duplicate, for example, a currency, you read it, and then the system says, gives the feedback, this is what it is. And then you see that there is some difference between the original and the duplicate. So it gives those corrections. Maybe the blue color is high, then automatically adjusts. Then next time it says red color is high, it adjusts. So likewise, it iterates and tries to bring very close to the original. Just to understand in colloquial terms, I gave this example of generative AI. And predictive AI uses a lot of statistics, You talk about regression model, time series, all those, and then it tries to see. So that's just to give a flavor about all these three. Now, how this is going to help in quality management? So we talk about machine learning. What is this machine learning? So whatever happens in actual, so the system tries to understand and store and tries to compare and tries to understand every time. It helps you in predicting and preventing quality issues. Next, it also helps you in optimizing process. And at last, it is helping you to improve the continuous process. Now, to give a little more detail, there are areas where we use today the vision system to try to see and understand how the dimensional errors, how the defects can be prevented. And similarly, we can use this for optimizing the process, for example, temperature, pressure, etc., vibration of the machines, right? And then we also talk about digital twins. What is this digital twin? I think one of our speakers is going to speak at length with all those applications. Don't get frightened by these jargons. These were there. When you ask me, when was this artificial intelligence started, it was in 1955. And we are talking in 2025. So it's not that new, and the digital twin is nothing but, you can see, it is like, I would say in simple terms, it is like a simulation with added on features of predicting. Maybe you'll get a better explanation in by the subsequent speakers. Now, you would have heard about all these things, these jargons: predictive analysis, machine learning models, computer vision. So all these things some of these use the statistical techniques like regression analysis, time series, etc. And in machine learning, what we call as supervised learning And then that is training the model with some labeled data and unsupervised learning and something called reinforcement learning. So I think we will be listening to some of our presenters today. And computer vision, I think most of us would also have implemented in our own areas like vision systems. There are many examples. I'm not getting into the details. Siemens is using extensively in terms of visual inspection. And similarly, Nestle, to segregate any, see, when the food products are supposed to be highly hygienic. So even if there is any contaminant, then that becomes unhygienic. So determining these unhygienic parts also is done by this AI. And then similarly, in all automobile manufacturers have used for various purposes. But let me come to what we do in Rane Madras Engine Component Division. See, we used to have a final inspection where we do 3 operations. We do a leak test of the valve, we manufacture valves, so we check the valves, we check the multiple parameters of the valve using a multi-gauge, and then we also do a visual inspection, and then it is passed. Till now, we have been doing manually. There will be a human being who will be doing. You can imagine how much monotony will be there for the people who are doing. Can you just click the tab? Now we have tried to do it for one of these lines. No, that arrow. Ah. Video. The wall which is picked by a robot and then place it on the leak tester. It checks for the leak. And once this is passed, it is taken to the next operation called multi-gauge, where it checks for multiple parameters using a robot. The multi-gauge operation is over, and once the result all are green, it is passed. It puts on to the green channel, green chute, which is good. And you can see there are multiple chutes which are for various defects. So it also picks and puts into the respective chute. So today we have implemented in a couple of lines, and now enormous data is being captured in terms of various defects. Now this can be, now we are having a team of people who will work on this to create an artificial intelligence where it can tell you which machine, which time, which process, how it should be addressed. Using the FTA, you have the complete fault tree analysis, it will go through and then give this. So that's what we are trying to attempt. And similarly, there is another example where we do an online SPC. You measure and just press the Bluetooth button, the data goes into the server. Now you have enormous data, it draws only the SPC chart. We can get various analysis from this, and that's where we are working on currently. So this is how we try to migrate towards the artificial intelligence application of AI. And the last one is on the security, data security. When we are going to use so much of data, we are at several risks. You have heard about a lot of things like this in the past. See, Air Canada chatbot commits 80% discount for the customer, so they lost money. And similarly, you have multiple threats. Last year, I hope every one of you would have got this cyber attack. We said that there are a lot of data being used, and we are now available on the web. So anybody can come and hack, and there is a data which says that when you compare with other countries, we are 3x more in terms of this type of vulnerability. So that's where I think the cyber security is very important. While we do all this in our factory, we should also protect it. So that's where we need to go into cyber security. So that's where I think some of our speakers will be speaking. I have taken more time than this. Thank you. With this introduction, may I invite Mr. Chandrasekhar Bharati, who is MD of ACE Micromatic. He is an MS from State University of New York with BE and PGDM from IISc Bangalore, and an entrepreneur and technology visionary. He serves as director of the board and at the IMTMA, Indian Machine Tools Manufacturers Association, and member of CA's National Manufacturing Committee. Currently is MD of ACE Micromatic. May I request you?
Please put your hands together and welcoming our session coordinator, Dr. R. Srinivasan, former chairman, Chennai branch, NIQR, to the stage. Welcome, sir.
Good afternoon, ladies and gentlemen. I have the distinct honor of either putting all of you to sleep or waking all of you up. So it's your choice. So I'm here to talk about how AI is used in manufacturing industries and what is the contribution that our group, ACE Micromatic Group, has been able to do for this in terms of the discrete manufacturing industry to start with. This one, right? Okay. Okay, there we go. So, whatever I'm going to talk about is in the context of who we are. We manufacture CNC machines, and this year we are going to manufacture 10,000 CNC machines. So, anything that we do, thank you. So anything that we do actually has to pass 3 gates. One is it should actually work from day one because you really cannot experiment with production machines in the field. In the same way, what we do with AI is part of the same stage gating process as well. It should work from day one. Second, it should provide value and ROI from day one, and an ROI that is literally measured in either weeks or months, not years. That's the second aspect. The third is it should be something that is structurally flexible to grow with the needs of the customer. So these are the 3 stage gates that we use when we do AI. And what I'm going to talk about today is how we approach AI. See, there's a lot of talk about Copilot and ChatGPT, and there's a lot of experimentation that happens with that. But when we look at industrial AI, there are so many aspects to what an industry does in the course of its day-to-day working. And our AI looks at it as a sum of the parts. It isn't just one thing that you do here, one thing that you do here, but we really try to connect all of this together. And here, I take inspiration from what Professor Motwani said in the previous session, what Dr. Joshi said, which is how to make this real, right? And that's the perspective that we have taken. And what we have done is, we've built a platform, much in the same way like how there is UPI that's transformed the financial industry. I mean, I don't believe that manufacturing has the luxury of having a unified interface like that completely, but that's where we are trying to go with this, which is like the UPI for manufacturing. So we have the ability to ingest data from a variety of sources. It could be production machines, sensors, metrology equipment, human factors, anything, right? And we've also put in new paradigms. What you say there is MIoT on CNC. It's actually a thin layer of software, IoT software that goes onto the CNC machines themselves. It's actually pretty revolutionary because what it does is it takes away one of the last friction points of how do you engage with the operator to become part of the whole Industry 4, Industry 5 paradigm. Again, the previous speaker, Ms. Esther talked about skilling the workforce. One is, of course, skilling the workforce. The second is making technology so easy to use that they, in some cases, don't even have to be skilled for that. So that's the other aspect. The second aspect of that is, how do you look at real-time aspects of what you do with data? For example, what do you interlock? What do you make sure that there is a digital thread that runs through the whole process, which, if it is compromised, things that need to happen to the process. So that is part of the, what we call a hot path. The warm path is near real time. You know, what needs to happen either by exception or by hour, or when a particular event is triggered, that type of thing, okay? What we have done with this is, with this infrastructure is, not only have we woven a digital thread across all the different operations of what happens in a typical manufacturing industry, we have enabled the ability to add virtually any kind of application. We are all familiar with, you know, the Android operating system or the Apple or whatever, right? Where there are so many apps, and those apps would not have been there yesterday. In the same way, manufacturing industries need use cases that will keep transforming and growing. That's the same perspective that we have brought to the application ecosystem. And through all this, there is an industrial AI tech stack. I'm not going to talk much about the technology behind it because that's going to take significant depth to go into. But what I'm going to show is